In physics, a spectrometer is an apparatus to measure a spectrum. Generally, a spectrum is a graph that shows intensity as a function of wavelength, of frequency, of energy, of momentum, or of mass. Optical spectrometer. Optical spectrometers, in particular, show the intensity of light as a function of wavelength or of frequency. The deflection is produced either by refraction in a prism or by diffraction in a diffraction grating. Mass spectrometer. A mass spectrometer is an analytical instrument that is used to identify the amount and type of chemicals present in a sample by measuring the mass-to-charge ratio and abundance of gas phase ions. Time of flight spectrometer. The energy spectrum of particles of known mass can also be measured by determining the time of flight between two detectors in a time of flight spectrometer. Alternatively, if the velocity is known, masses can be determined in a time of flight mass spectrometer. Magnetic spectrometer. When a fast-charged particle enters a constant magnetic field B at right angles, it is deflected into a circular path of radius r. Due to the Lorentz force, the momentum p of the particle is then given by, where m and v are mass and velocity of the particle. The focusing principle of the oldest and simplest magnetic spectrometer, the semi-circular spectrometer, invented by J.K. Danish, is shown on the left. A constant magnetic field is perpendicular to the page. Charged particles of momentum p that pass the slit are deflected into circular paths of radius r equals p, q, b. Evidently, they hit the horizontal line at nearly the same place, the focus, where a particle counter should be placed. Varying b. This makes possible to measure the energy spectrum of alpha particles in an alpha particle spectrometer, of beta particles in a beta particle spectrometer, of particles in a particle spectrometer, or to measure the relative content of the various masses in a mass spectrometer. Since Danish time, many types of magnetic spectrometers more complicated than the semi-circular type have been devised. Resolution. Generally, the resolution of an instrument tells us how well two close-lying energies can be resolved. Generally, for an instrument with mechanical slits, higher resolution will mean lower intensity.